In this video, we are going to take a look at question 7 of practice exam 2, and we are reviewing chain rule. So here we've got two independent variables, s and t. And generally, you might have one or two, but the fact is that their answer will be very, very similar. So we're just going to have to do it twice if we have two variables. So we got sine of x plus y is our function of x and y, but x itself is a function of s and t, and y is also a function of s and t. Now let's draw a diagram that can help us answer the questions about the chain rule. So I like to actually call the z, they call it f. I kind of don't like this notation, but whatever. So what I do is I start with z and I draw that z depends on x and y. And then in turn, x depends on s and depends on t. And y also depends on s and depends on t. Then I fill out the partial derivatives. So this will be dz dx, this will be dz dy, and these are indeed partials because the function z has two variables x and y, so I need the partial symbol. And then also here we'll also have the partials because we have more than one variable. So we got dx dt here, dy ds, and dy dt. Okay. All right. Now let's see if we can find the two derivatives. Okay. So which ones? So first of all, with respect to s, so we are following the branches that will lead us to s. So that'll be this one, and that'll also be this one right here. Okay, now in order to find that, let's find all the partial derivatives. First, let's find the partial derivative of z with respect to x. Okay, so we've got sine of something. Now you should know that the derivative of sine of something is cosine of the same something by regular chain rule multiplied by the derivative of the something. So that is the chain rule. That's the way that works. Okay, so let's take a look. So we've got sine of x plus y is going to be cosine of x plus y. So that's not going to change. Multiplied by the derivative of x plus y with respect to x. So here we got addition. And whenever we add terms, we're just going to take the derivative of each term separately and add them up. Derivative of x with respect to x is 1. And derivative of y with respect to x, because it doesn't have an x, is 0. So that's our partial with respect to x. Now, very similar because they are the same, x and y. If you switch them, you get exact same thing. This is also going to be cosine of x plus y. This time, the x will become 0 and the y will become 1, but the answer will be exactly the same. Now let's take a look at the partial derivatives of x with respect to s and also x with respect to t. Let's take a look at that. Now here we have a very important distinction. We've got a product of two terms. We have only one term, but it's a product of two terms. Now, when you take the derivative with respect to s, you're treating t as a number. So the t to the power 6 is also going to be a number. And because it is multiplied by your function, this is constant multiple rule. The number is kept. We don't drop it. If it was added, we would drop it. But because it's multiplied, we don't. So we need to keep t to the 6 as a number, constant multiple, and then take the derivative of s squared normally, which will give us 2s. Okay? Now, let's do the same thing, derivative with respect to t. This time we treat s as a number, so that s squared right here is going to be a number, okay? Just like before t to the 6 was a number, now s squared is a number. And constant multiple rule says that we are going to keep it. And then multiply by the derivative of t to the 6, normal one, which is 6t to the 5. Okay, so we dealt with x. Now let's take a look at y. So we want to find the derivative with respect to s and with respect to t. First, let's find with respect to x. Now, y has two terms that are subtracted. So we need to take the derivative of each separately. Derivative of 2s with respect to s is 2 minus derivative of 6t with respect to s, because 6t is just a number and it's added or subtracted, the number drops out. So it's not multiplied, we don't keep it, we drop it. That's the difference. For derivative with respect to t, the first part, 2s, is a number and we get 0. And then the second part will just give me 6. So this is just going to be 2. This will be negative 6. Okay, so with that said, let's see if we can follow the tree. And we want to find the derivative of z with respect to s first. So we're going to take dz dx, which is just cosine of x plus y. And remember, the other term was just 1. Multiply that by dx ds, which we got over here. I'm going to just reorder it. So I'm going to put 2t to the 6s. Okay, so usually we put the number in the front. So that's the first part. Following the other branches, this will be dz dy, but that's the same, cosine x plus y. And then dy ds, well, we got that here, and that's just 2. Okay, now that would have been the final answer, but what is important is that you cannot leave it like that. You gotta plug in everywhere where you see x, you plug in what it was in terms of s and t, and then everywhere where you see y, you plug in what that was. But I can just go ahead and do that here. So I will get cosine, and I'm not gonna put x, but I'm gonna put s squared t to the 6. Then plus y, which is 2s minus 6t. Okay, so I got that. Multiply that by 2t to the 6s. Now I'm going to do the same thing with the other one. I'll just put 2 in the front, and then again, cosine of x plus y. Okay, I think I'm done with this one. Now let's take a look at the second partial. So we want to know what is the partial of z with respect to t. Now this is going to be similar in terms of the cosine. It's just going to be x plus y. But this time we're going to follow this branch and this branch, right? And then we're going to follow this branch and this branch. Okay, so we're going to multiply by dx dt, which I got as 6s squared t to the 5. Okay, the other derivative is also cosine of x plus y. And we're going to multiply by the derivative of y with respect to t, but that was negative 6. So I think I am done here, but again, instead of x and y, I have to plug in what they are. So I'll get the same thing. Okay, and then multiply that by 6s squared t to the 5. Again, a plus, the same cosine. We could probably factor it out, but I'm not sure that that's necessary. Unless we have to simplify, we do not have to do anything else here, and we're done.